Let's build a machine learning model to predict if your date is a red flag. Real code, a real model, and fake data. Here what we are building a red flag detector. You need to answer 10 yes/no questions about your date. And the model predicts red flag or safe to proceed. We will use logistic regression because it is simple, but it will show you the entire machine learning workflow. So let's code. First of all, we will import pandas. From sklearn, we will import train test split as well as logistic regression model. Now we are entering our training data based on the 20 past dates. So our data will have questions like talks about X, route to waiter, on phone, constantly talks about money. We're using encoding and we spoke about encoding in a different video. With our target 1 equals red flag and 0 equals safe. So 10 features, all yes and no questions. 1 means yes, 0 means no. And target column is red flag or safe. Now we need to split our data into features and target, and after that we are splitting data into train test split. So test size is 20%, so 80 is training data, 20 is testing data. Random state, you can use any number, you use it so you can reproduce the same result again and again if you want to. Now we need to train our model. We will train our logistic regression. After that we are checking for accuracy. So you need to split the data, train the model, 3 lines of code, and that's it. The model learns which pattern equals red flag. We got 100% accuracy on our test set, tiny data set, but it works. Now we need to make our predictions. If prediction equals 1, then it is a red flag and our model will print a run, don't walk. In other cases, our model will print a look safe and proceed with caution. So our new date scored 7 out of 10 red flags and our model says run. The next part is feature importance. Which features matter most? We will create a horizontal bar chart to find which features matter most. So you can see that a route to waiter ignores boundaries are important. The model knows. Obviously, this is silly data, but this is exactly how real machine learning works. First of all, you need to collect label data. Let's call it past examples. Then you need to train a model, learn patterns. After that, you make predictions, new examples, and at the end, you interpret results, which is feature importance. Exactly same process applies for fraud detection, spam filters, medical diagnosis, and loan approval models. You use different data, but the workflow is exactly the same.